Hey everyone, in today's video we're going to talk about AI agent recipes and how we can use them to upgrade our AI agents and LLM applications. This agent recipes is prepared by Together AI, and Together AI is a company that offers cloud-based tools for deploying open-source generative AI models. And the materials I'm going to cover today, you can find all the information on agentrecipes.com. They have prepared the code examples on the website, and we have prepared the relevant end-to-end workflows for you so that you can just copy and paste to your own end-to-end AI agents workflows. And at the end of this video, I will share with you where you can find this end-to-end template. So let's get started. We are going to cover 5 major workflows for 5 different AI agents recipes. The first one is prompt chaining. The second one is routing. The third one is parallelization. The fourth one is Orchestrator-Workers. And last but not least, it is the Evaluator-Optimizer. So we have prepared all the end-to-end workflows for each recipe. So let's talk about the prompt chaining first. So for this chart, it is showcasing how it works. Basically, it is a workflow where the output of one LLM call becomes the input of the next LLM. So it is a sequential design which allows for structured reasoning and step-by-step task completion. The use case can be, for example, like generating marketing copies and then translating into different languages, writing an outline of a document, checking that if the outline meets the certain criteria, etc. And we can also use this flow to clean and standardize raw data and then pass the cleaned data to other LLM for insights and summaries or visualizations. So let's take a look at this workflow and do a quick demo. Great, let's take a look at our first workflow, which is prompt chaining. Again, it is a workflow where the output of one LLM becomes the input of the next one. This is a sequential design. So basically, let's dive into the notes one by one. We're going to use these sample questions later. So for the first note, let's take a look at that. We will take from previous note automatically for the prompt, and then a chat message. If using a chat model, the type name we use system. The message, let's take a look at that. Given the math problem, only extract any relevant numerical information and how it can be used. And we are using MetaLlama 3.17b 70b model. For the second one, it is for showcasing the steps. So again, the type name we choose system. The message which we put, given the numerical information extracted, only express the steps you would take to solve the problem. So the deliverables will be the steps. And then for the third one, it's just generate the final answer. We are using MetaLlama 3.170b as well as a model. And then the message is, given the steps, express the final answer to the problem. So it's like a chain for working for different for doing different tasks with different deliverables. So let's take a look at the results. So let's try with these sample questions. All right, and then we can click test chat here. All right. Sally earns $12 an hour for babysitting. Yesterday she just did 15 minutes of babysitting. How much did she earn? So let's take a look. Great. So let's take a look at the thinking process. Let's see the execution. All right. Let's zoom in. Of course, the first one is the message that we input. This is the question. And then for the first node, it extract the relevant numerical information and how it can be used. So it got the relevant numerical information, which is this and this. And it helps to convert the babysitting time from minutes to hours as well. Yeah, so basically just multiply Sally's hourly rate by the babysitting time in hours to find her earnings. And for the second node, let's take a look at that. Given the numerical information extracted, only express the steps you would take to solve the problem. Okay, so this is our first step. First one, to multiply Sally's hourly rate by the babysitting time in hours, 0.83 hours, or 5/6 hours. And then the second step is to perform calculations, which is $12 times 0.83, which equals to $9.96. All right. For the third node, which is to get the final answer, let's take a look at that log. Based on the given steps, there were 2 steps given by the previous nodes. There are 2 final answers due to the different methods used. $9.96 using decimal hours, and $10 using fraction hours. Great. Basically, this is the demonstration of using the prompt chaining for this question. All right, by the way, if you want to add specifically this node, you can search basic LLM chain here, or you can use other LLM node as well. That works. All right, after talking about the first workflow called prompt chaining, let's talk about the second one called routing. As you can see from this image, the workflow is shown when input is processed through the LLM code router. It is classified and directed to a specific task. For example, and like for different tasks will be done by different LLMs. Easy tasks, for example, will be directed to the smaller models like Llama 3.18b, and for hard or unusual questions will be directed to more capable models like DeepSeek version 3 or Llama 3.37b to optimize the cost and speed. So for the use cases, maybe like directing different types of customer service inquiries, like general questions, refund requests, technical support, etc. And for example, like different LLMs or models configs excels at different tasks, like writing summaries versus generating code. Using this router, you can automatically detect the user's intent and send the input to the best fit model. Basically, it is how the routing works. All right, let's take a look at the demo here for the AndyNoCode workflow and see how it works. Okay, so let's connect this chat message trigger to this, and then let's open the chat. So basically we have 3 sample questions. Produce Python snippet to check to see if a number is prime or not. Plan and provide a short itinerary for a 2-week vacation in Europe. Write a short story about the dragon or ending night. How about let's do the third one. Let's do the story writing. Okay. Great. We can see the result is here. It's pretty decent. Okay. But more importantly, let's take a look at the execution workflow and the details and see how it works. First of all, once we receive the chat message, it will be processed through this node. So for this node, we can add through edit fields. This one, we can rename it to routing chat here. All right. So for the mode, we use manual mapping, and fields to set, we choose chat input, and then we can just drag and drop this JSON.chat input here. And for the models route, we choose object here, and then let's take a look. And then for this model, it is best model choice for code generation task. And then for this model, as for storytelling, role playing, and fantasy tasks. And for this, it's the best model for reasoning, planning, and multi-step tasks. You can change it in the model that you think is the best for the specific task. So these are just examples. All right. So these are the model routes here. And then this node is the LLM node routing prompts, and we use MetaLlama 3.170b as well. And we take from previous node automatically, require specific output format, and then for type name or ID we choose system. So let's take a look here. Given a user prompt or query, which is the chat input, we can drag and drop here. Select the best option out of the following routes. And then because in previous nodes we have the routes done already, you can just drag and drop as well. All right. So what we need to do is to join the space between them, the new line. So basically we can just output in this format and answer only in JSON format. All right, so you can just copy and paste this prompt. All right, and then here we use structured output parser, which is this. Let's take a look at that. Type object properties, route type string. This one for the model name, and reason type string required route reason, additional properties false schema, JSON schema.org. So basically you can also copy this input schema. All right, so we can see the output here, which model it is trying to use, and the reason is provided here. It is the best model choice for storytelling, role playing, and fantasy task. So that's why this LLM will choose this model for that specific task. All right, and this is the main function node. So for the message, we will just input the routing chat here, which is an input. All right. For the chat input here. All right. For the model, we choose the routing model. Here we will use the Together AI for choosing the right model. For which model we are going to choose, we will need to refer to the previous node, which is to get the output for the route. So basically, for the previous node, we choose which model to use, and then in this routing model, we are going to pick that particular model to use. And this is the base URL. You can just copy and paste here: api.together.xyz/v1. And last but not least, this is the output for the storytelling. And that's how we can use this workflow for choosing the best model for a specific task. Basically, easy or common questions using the smaller model, hard questions using more capable models. is to optimize and save cost and speed. And by the way, I would like to highlight two things. The first one is to how we can add this node. As you can see, this is the OpenAI logo. We can actually choose OpenAI chat model, and we can choose together as a credential to connect with. As for the model, we don't need to specify here. We just click expression, remove that, and then we can just copy and paste this. Basically, this is the results from the previous node. So we can, when you try to run it, you can just drag and drop this as the model and put it here. All right. And the second thing I would like to highlight is how we can actually connect the together AI credentials. It's very simple. Again, we can go to credentials and then add credential to projects and choose OpenAI. And basically, you can just paste the API key of your together AI here and nothing else, and it will be connected successfully. All right. After talking about the second workflow routing, let's talk about the third one. For the third workflow, it is called parallelization. So basically, it means that we will break down the tasks into different independent parts, and then so the user prompt will be passed to multiple LLMs simultaneously. That's the key words, simultaneously. So once all the LLMs respond, the answers will all be sent to a final LLM to be aggregated for the final answer. All right. For example, when we need to analyze a lengthy document, we can use this workflow to divide it into sections and assign each section to a separate LLM for summarization, then combine the summaries into a comprehensive overview. And another example will be like translating a document into multiple languages at the same time by assigning each language to a separate LLM, and then aggregate the results for multilingual output. Great, let's take a look at the demo now. Okay, so let's put this chat message node here to the third workflow. All right, and for the sample question we are using this time as this Gina and her mother picked some apples from the apple farm. Gina picked half as many apples as her mom. If her mom got 20 apples, how many apples did they both pick? Let's try this question. Copy and paste to chat. Okay, you can also take your time to try to think of your answers as well. All right, so we have many answers from different models. So let's take a look at the answers. All right. Gina picked 10 apples. Picked 30 apples. Okay, answer is 30. Okay. Okay, so basically we got the correct answer from different models. So let's take a look how the workflow works and how each node works as well. So for this first node, we can add edit fields again, this one, and we can rename it as set global variables. For the mode, we use manual mapping. For model, reference model, we choose array here. These are the models we reference to. All right, for the second part, it is the aggregator model. We use DeepSeek AI v3 as a model, and then for the type, we choose string. For the third part, it is aggregator system prompt. Again, we use string as a type. So for the expression inside, we put this as a prompt. You have been provided with a set of responses from various open source models to the latest user query. Your task is to synthesize this response into a single high-quality response. It is crucial to critically evaluate the information provided in these responses, recognizing that some of it may be biased and incorrect. This part is very important. Your response should not simply replicate the given answers, but should offer a refined, accurate, and comprehensive reply to the instruction. Ensure your response is well structured, coherent, and adheres to the highest standard of accuracy and reliability. Responses from models. All right, and then for the chat input, we just drag and drop this one here. For the split out, we can search from here. Split out. It is for turning a list inside items into separate items. Let's take a look at that. For fields to split out, basically this is the field. We can just copy and paste this. Include no other fields. And you can see it is separated already. And then for this node, we can choose from here, basic LLM chain. Let's take a look at that. Prompt, we choose define below, and text, we can just drag and drop this one, set global variables, and then chat input, drag and drop this one. And for this part, again, we choose the OpenAI node here, and then it should be chosen from here. You can choose this and choose OpenAI chat model. All right. And then we just rename it into multimodal because the most important part, we need to connect with the Together AI credential. And then for the model, we can just choose here, drag and drop this one. All right. And then base URL, we choose api.together.xyz/v1. After that, we need to aggregate, combine the field from many items into a list in a single item. All right, we aggregate individual fields, and then for the fields to aggregate, input field name text. Basically, it's this one, because there are outputs from different LLM models. We just need to output that. We just need to aggregate that. And after that, we will use a DeepSeek v3 as the aggregator agent. Again, this basic LLM chain, we will just rename it as the aggregator agent, and prompt we choose define below. And we just, at the beginning, we set the global variables as the aggregator system prompt. We can just drag and drop here. And then we can just, you can just, let me open this. For this one, is for the formatting to joint /n/n for the new line. You can just copy and paste as well. And this is the number of the answers, number of answers. So basically like this to better illustrate the order of different answers. For the DeepSeek model, again, we can choose OpenAI, the node, choose it from here, and you can edit here and then choose OpenAI chat model, but just connect with the Together AI credentials, and then we can choose DeepSeek AI / DeepSeek v3 model. Again, this is the base URL. You can just choose this. And last but not least, we can get, again, edit fields. This one. And this is to return results. Aggregate item All right. We can just copy and paste this, and then final answer we can just put this. All right. Let me show you. So on the right hand side, it is the results. For the upper part, it is to the aggregated immediate response. All right, aggregated immediate response from different models. And then for the final answer, it is processed through the aggregated agent, which is DeepSeek v3. This one. So basically, you can see different answers from different models, and also the aggregated answers, final answers from the DeepSeek here. All right. So basically, this is a demo for the third workflow called parallelization. After talking about the third workflow, let's talk about the fourth one called Orchestrator-Workers. As you can see from this workflow diagram, this is the input and this is the core orchestrator. It means that this LLM node is going to break down the task into subtasks. And then these are the LLM to process the subtasks. So basically, the subtasks are then processed in parallel by multiple workers LLMs. And finally, this orchestrator LLM will synthesize the workers' outputs into the final result. For example, the use case can be breaking down a coding problem into subtasks, using an LLM to generate code for each subtask, and making a final LLM call to combine the results into a complete solution. And the second use case can be searching for data across multiple sources, using an LLM to identify relevant sources and synthesize the findings into a cohesive answer. Or the third use case can be creating a tutorial by splitting each section into subtasks, like writing an introduction, outlining steps, and generating samples. And the worker LLMs will handle each part, and the orchestrator will combine them into a polished final document. So let's take a look at our demo here on NN. All right, so let's connect this chat message node here to the fourth workflow. And our sample question this time is to write a production description for a new eco-friendly water bottle. The target audience is environmentally conscious millennials, and key products features are plastic-free, insulated, and lifetime warranty. Let's copy and paste to the chat. Let's format it in a better way. All right. Start. Okay, so we can see this is the output. Worker results, formal, key features, conversational. All right, hybrid. All right, it's pretty decent as well. Okay, so let's take a look at each node one by one. For this node, again, we can edit from basic LLM chain, and let's take a look at that. Prompt we choose define below, and then we analyze this task and break it down into 2 to 3 distinct approaches. The task, we can just drag and drop this. Provide an analysis, explain your understanding of the task and which variations would be valuable. Focus on how each approach serves different aspects of the task. Along with the analysis, provide 2 to 3 approaches to tackle the task, each with a brief description. And then for the formal style, I'll write technically and precisely, focusing on detailed specifications. For conversational style, write in a friendly and engaging ways that connects with the reader. And the last style will be hybrid style. Tell a story that includes technical details, combining emotional elements with specifications. Return only JSON output. So that's why we have 3 different styles in our output at the beginning, what's shown in the chat here. All right. For the model, we choose Meta Llama 3.170b. Base URL, we put this as well. And then we need to turn on require specific output format. For structured output parser here. So type, object, properties, analysis type. You can just copy and paste this as well. So formal, conversational, hybrid as different types. Then the next node we have is the split out node. We can search it here, split out, to turn a list inside items into separate items. All right, let's take a look at that. We choose output task, this one. So we just need to separate them so we can see different types and different description. For this, we can also choose LLM and then basic LLM chain. We just rename it as work model LLM, defined below for the prompt. We just input generate content based on task, and then we can just drag and drop here. Drag and drop this one. Style, we can drag and drop the type here. Guidelines, we can drag and drop of the description here. Return only your response, your content here, maintaining the specified style and fully addressing requirements. All right, so basically it's how it works for this part. We use MetaLlama 3.170b as well for the model. And after that, we will aggregate everything. So we choose aggregate here to combine a field from different items into a list in a single item. All right. So let's take a look at that. Individual fields, input field name text. Basically, this is how it works. And last but not least, after you aggregate it, we can just add this node. And for this node, it's just add the fields. Okay. Let's take a look. Details inside. Menu mapping. For the fields to set, we choose text. And then we put string as type. Analysis, we can just drag and drop the orchestrator prompt items output analysis to share the task analysis. And then for the task here, we need to JSON stringify the output here. All right, basically these are the output: the formal one, the conversational one, and the hybrid one. All right. For the worker results, basically this is the end result here. Worker result for the formal, worker result for the conversational, and worker result for the hybrid. All right. Yeah. So again, please copy and paste this, and you need to join the new lines for better formatting. All right. Yeah, basically it's how it works. And that's it for the fourth workflow, Orchestrator-Workers. All right, let's talk about the last workflow, the Evaluator-Optimizer. Basically, this workflow ensures task requirements are fully met through iterative refinement. And LM perform a task, it will be followed by a second LM to evaluate whether the result satisfied all specified criteria. If not, the process will repeat with adjustments, continuing until the evaluator confirms all requirements are met. So for example, the use case can be for searching for information and using an evaluator to verify if the results are including all the required materials, and also, for example, writing stories or article with specified tone or style requirements, and using an evaluator to ensure the output matches the desired criteria. And then, for example, generating structured data from unstructured input and using an evaluator to verify that the data is properly formatted, complete, and consistent. And another use case can be creating user interface tags like tool tips or error messages, and using an evaluator to confirm the text is concise, clear, and contextually appropriate. It is making sure the result satisfies all specified criteria. So let's take a look at the demo now. Okay, let's take a look at our demo for the fifth workflow, the Evaluator-Optimizer. Let's put the chat message received note here. And the sample question we are going to use is this one. For the goal, we are going to generate clear, concise tooltip text for a download report button that explains the file format, mentions file size, uses friendly languages less than 15 words, and maintains a consistent style. So let's copy the sample question and start the chat. All right. Great. So this is the thought. This is the response. Great. This fits the criteria. So let's take a look at each note one by one. First of all, again, we can add edit fields. This one, and then we rename it to context here. Mode, we use manual mapping. As for the fields to set, we input context here, and the type we put string. And remember, we leave it empty for now because we are going to use this two nodes to reference to this context node. All right. So for this one, we add the basic LLM chain again, and then for this time we use Qwen 2.5 Coder 32B model. Defined below. Basically, the prompt is your goal is to complete the task based on user input. If there is feedback from your previous generations, you should reflect on them to improve your solution. Output your answer concisely in the following format: thoughts and response. All right, and then we can just drag and drop the task here. When chat message received, and then drag and drop here the input, and then JSON context to drag and drop this one. All right, and then you can see this one. This is task. All right. As you can see, this one. Let me show again. This is a task. And then it will show the JSON context. It is referent to this two nodes later. So I will further explain that later. And for this node, we name it as evaluate prompt. And the prompt we use evaluate this tooltip text against the requirements. So these are the requirements we have. So we need this node to try to evaluate if the output generated from the previous nodes are fitting these criteria. You should be evaluating only, not attempting to solve the task. Only output pass if all criteria are met and you have no further suggestions for improvement. Provide detailed feedback if there are areas that need improvement. You should specify what needs improvement and why. Make sure to only use a single line without new lines for the feedback. Only output JSON. Original task, and we can just drag and drop this. Content to evaluate, we can drag and drop this one. Generate prompt, which is from the previous node. As you can see, on the right hand side is the output. And then turn enable requires specific output format. So the structured output parser here. you can just copy and paste this. Type property, values type, and then we put a past needs improvement val here. All right. This is the model we use. Again, we use the Together AI as a credential to connect with. And we need to add the if node here. You can search it here, if. Why? Because we need to see if the results are fitting the criteria. If it is equal to pass, that means it's okay. We can just pass the result. If not, we need to regenerate the output again. So for this one, we can just drag and drop this item here. Expression is equal to pass. There are many two results, true or false. That means pass or not. So for the first node, we can choose, again, we can edit here, edit fields. And then we can rename it return results. And manual mapping, we choose text, string as type. Generation start. And basically, we can just drag and drop this one here. All right. And then if it is false, we will try to evaluate. So manual mapping, context. So it is referring to this. All right. So we can see previous attempts. Basically, it is this one. You can drag and drop. Feedback. And this one is the feedback. Okay. So basically on the right hand side is this one. So basically this is the whole workflow. As you can see for this node, we can see JSON dot context here. So if it is not fitting the criteria, this one will be replacing the context. So this one, the whole thing will be inputted as here. So basically, it is for the improvement to refine to further generate the correct output that can pass through the evaluation. So yeah, basically this is the demonstration for this workflow, the Evaluator-Optimizer. So for this workflow, it can make sure that your output can fit the criteria through iterative refinement. And these are the 5 AI agent recipes that I would like to share with you guys today. Feel free to let me know what you think about this in the comment section below. And we're going to share this template in our school community. So feel free to download this recipe from there. And let me know what you think about this tutorial. See you in our next video.